Dynamic host configuration protocol. Dynamic host configuration protocol. Can anyone say what it is? Not anyone. Pavitra, no. Other two. Can you say what DHCP is, or what do you know about DHCP? You tell me, please. Wonderful. Devices, network devices. So it assigns the IP address. That's what here it means. Configures. The host means devices. What it configures? IP address dynamically. So DHCP is a protocol that we run on both the server and the client, and that protocol will make this happen. That protocol will make the client to request and server to respond. See, you already got one answer. Who initiates what? It is the client initiating the DHCP process. Server will not come in search of client and give an IP address. Server won't do that. Server will not come and say, hey, I think you need an IP address, take this. No. It's the host. Go in search of a server, request for an IP, and DHCP server will respond by giving an IP. So here we know who is the initiator and who is the responder. A client is who? Every host that needs an IP address to be configured is a client. Any host that needs an IP to be configured is a host. So we have a computer which have got no IP address at all. No IP on A, no IP on B, no IP on C. But it has got a unique address which came along with the purchase. We call it as MAC address, right? Let's say the MAC address of this PC is AAA, and this is BBB, and this is CCC. So we got three device which has got no IP address, no layer 3 address. Only with this MAC address it has to manage communicating to a server here. So communication happens without an IP. Yeah, it's true. So no IP to this PC, no one has given IP address, but the server, why I call it a server, it is enabled with the DHCP service in order to serve IP address, in order to provide IP address. And also the server will have an IP address manually configured. This is an IP address that I have manually configured on the server, and I have also enabled DHCP service. Have you enabled DHCP service anytime? Anyone? In your home you have internet, right? Now without internet you will not be able to join the class, so definitely you have it. In your home you have a small box, no, where you get the internet. That box, if you log in, usually these guys who provide you internet, they don't give the password. Why they are not giving? It's your box, they should give. Log in, ask them the username and password, log in. There you will have DHCP tab under the wireless. There will be wireless tab at the menu, some menu, it depends on what vendor box you have, Linksys or Cisco or 3Com, or I don't know what box you have in your home, Huawei, Depending on depending on the vendor, the page will slightly differ, but definitely it will say DHCP only. Any vendor device it may be, you will see automatic IP address configuration DHCP mentioned there. And if that checkbox is enabled, automatic IP address configuration checkbox is enabled, it means that DHCP service is running. It's simply a software, that's it. DHCP server is what? The big computer or small computer, whatever, that runs that software which can throw an address on demand. That's a DHCP server. It's not a special server and all, right? And you can make use of even a simple laptop to be a DHCP server. It's just a tool, small tool that you install and you configure. Now, that becomes a server. As soon as you enable this DHCP service on this device, it becomes a server. Even a Cisco router can be a DHCP server. If you go inside Cisco router and enable DHCP, then it becomes a DHCP server. So when we enable DHCP server, what we need to do is we need to provide a pool, address pool. We need to say, if someone is coming to you asking for address, give address from this subnet and this mask. And you can also give gateway. And you can also give DNS address. All these a DHCP server can give to the clients, to the hosts. A, B, C, these three are the host. See, we have given the entire 10 network in the address pool. And in that 10.0.0.0, we have already consumed one address, so it won't give. Starting from 10.0.0.2 till 10.255.255.255. Actually 254, 55 is broadcast. These many address, this range of address is there in the pool. So if this PC is coming and asking for address, 10.0.0.2 will be given. How it will be given? The server will say, someone with CCC came to me. To that someone I have given this address. And now when this guy goes and asks for an address, it will say, someone called BBB came to me. I gave the next address. And when this asks for an address, it will say someone called AAA. I gave 10.0.0.4. You know, this is what called as DHCP binding table. This table is maintained in the DHCP server. Whether it is Cisco's router acting as a server or the wireless access point that you have in your home, they all maintain this table. It will show you to which MAC address device I gave this address. Automatically it will give. Now, when it gives, for how many hours it will give? By default, it will give for 24 hours. 24 hours. For 24 hours, the address is given as a lease. That's the lease time. For each computer, it will say, I am giving for 24 hours. You can alter this actually. Some devices will allow you to alter. In your home network, you have the wireless access point, right? If you log in, you may have an option, lease hard. By default, you will see that 24 written. You can say, no, every 5 hours you change. Yeah, you can say that. Every 5 hours. You can change every 1 hour. Now, let's say 24 hours lease, you got an address now, but even after 24 hours, you are working, your computer is active. Will that IP address be same or will it be changed? It will be same. See, even though address is leased for 24 hours, when the 24th hour ends, the device should be inactive in order to take back the address. If the device is up, that same address will be extended again another 24 hours. Okay, so the lease time by default is 24 hours. Now we are going to start understanding how this possible. When these PCs do not have an IP, how can it send the packet out? Where is the OSI layer here? OSI layer should have all 7 layers info. Layer 3, there is no IP. Then how is this DHCP can work? Right, how DHCP can work if there is no IP address? It is possible because of layer 2 broadcasts. Layer 2 broadcast. With the help of layer 2 broadcast, this is possible. I'm going to show you this first and then I'll come back and I'm doing exactly what we discussed in the paint. I'm creating a pool. Let mask. No? Okay. I can straight away say the mask. 255.0.0.0. And then I'm saying from this network you should give an address. And then I'm going to say as a gateway to all the computers and routers that gets IP address, for them the gateway should be 10.0.0.1. And also I'm going to say DNS should be 8.8.8.8. Fine, so this is now ready to serve. This is the DHCP server. I have enabled DHCP. And this one interface I have given this 10.0.0.1 address, that you can find it here. I went under this interface called F00 and then I have put this address. And the other things are DHCP server configuration. I configure DHCP server. Now show IP DHCP binding. You see the table is empty now. The reason is the clients are not yet configured. The clients are not ready to request for an address. The clients are not ready yet. Okay, so we are going to enable Wireshark, where you can see the packets very detailed, who is sending what, from where, what is going. You know, this Wireshark is a wonderful tool. I teach a separate course on Wireshark, 4 days training, 4 full days, 4 working days. Wonderful training. It's a very important tool for troubleshooting and also to study things. Now you see we are learning DHCP, we are trying to understand DHCP using this tool so that you can understand DHCP better. As of now I am not getting any packet from any DHCP related packet. I got Cisco Discovery Protocol packet, and then these are all simply, connectivity check loop. Now, let me go to this PC first and say console, and then I'm going to configure this PC. Oh no, maybe it's down here. I'm going to configure this PC to receive IP from the server. IP DHCP. You see there is DD. What is this DDORA? What is this DDORA? Look at this. It has already got the IP address. Not only that, it also got the gateway automatically. Now let us go to this one. You see that DD now? This is the D. 2D you saw now? To discover packet. Let us open this discover packet and see how it looks. This is Ethernet header. We are not into layer 1. And now we have Ethernet. Look at this. This is the source MAC address of the PC, and this is the layer 2 broadcast. In the other class I told you, layer 2 broadcast address will be 12F. ARP will send similar packet, layer 2 broadcast. And see the layer 3 header. There is no source IP, but there is destination. Now what does this 0000 means? It means any address. See, it is not sending a blank one. All 7 layers of OSI should be there. It's not sending a blank. It sends at least some number 0.0.0.0 to make this packet a qualified packet. Layer 3 should be there, no? And you see the destination broadcast. It's a layer 2 broadcast, agreed. See, you should not say layer 3 broadcast. It's a layer 2 broadcast, but in the layer 3 field you will see layer 3 broadcast address. But this packet will be circulated only within the LAN. It's layer 2 broadcast. And it uses 68 and 67. See, the discover packet is using 68. Source, client is using 68. And it is talking to the server with 67. DHCP uses port number 6867. Don't forget. DHCP port number is 6867. If you have notebook somewhere, you write it down. DHCP port number UDP 6867. 68 is used by client, 67 is by server. And this is a discover packet successfully sent. Hold on. All right, and then an offer came from the server, and then a request went from the client again, and then where is the acknowledgement? Okay, here it is. ACK has gone top. I don't know how. It's going in descending order. That's why. Wait a minute. It's okay. This is the right order. Discover offer request acknowledgement, and then ARP goes. You see ARP. ARP is also a layer 2 broadcast. Do you see FFFF? And this is address resolution protocol request. And you will also see ARP reply somewhere. Okay, we'll focus on ARP later. When you ping, you only will get the reply. Not focus on that. Now let's finish DHCP. As I said, discover packet is a layer 2 broadcast. It doesn't mean that it will not have a layer 3 address. See, this is where the interviewer will twist. Okay, DHCP is a layer 2 broadcast packet. So will there be a layer 3 address? If you say no, it is wrong. Why? Because it won't be a qualified packet. There should be some address in layer 3. So what address is there? 0000 any. That means any. Source. And the destination is 255.255.255.255. Any network to any destination. It's a layer 3 broadcast, but actually it's a layer 2 packet. Because it's a layer 2 packet, layer 3 has got this 255.255.255.255 as the destination. That is going from the client. Now the server is offering, it comes with the IP address 10.0.0.1 to 10.0.0.2. Who is 10.0.0.2? PC. But when did PC receive that IP address? Now only it is receiving, but it is simply putting this address actually. It is responding to 0.0.0.0 with an address, but this address is still not given to the PC. It is given only in this acknowledgement. In the offer, it is just proposing. You can see that here. Open this. It says, hey, I want to give you this address. I want to give to this guy who gave this MAC address, I'm giving this address. I'm planning to give. It's an offer. It is not an acknowledgement. It is not granted it. It is just proposing it. It says, I am the server. I'll give you that address. I'll give you this mask. And I'll give you this router's IP address as a gateway. And I'll give you this DNS if you request. It is simply sending an offer. If you ask, I will give you these things. So this guy, what he does, the client is again sending a broadcast requesting. You told me you will give me. Will you give it? See, that's a request. See, it says, hey server, you said you will give me this address. Will you give me this? And now the server says, why not? I'm giving you for 12 hours. Okay, Cisco router is 1 day, least time, correct, 24 hours. So, now it says, okay, I grant you the address. It's an acknowledgement. I grant you the address. This is your address officially from now. And I grant you for 24 hours, 1 day, least time. Renewal time is 1 day. A rebuild time value is 12 hours. Subnet mask 21 hours. Router gateway, DNS, all these things are given. But it is only granted in the last packet called acknowledgement, not in the offer. In the offer, it is simply saying, I will give you this if you request. So if you notice, from the client side, it was only a broadcast. Everywhere broadcast. From the server side, it comes as a unicast. See, offer is coming from the server, DHCP server, 10.0.0.1. Who is 10.0.0.1? It's server. If you open this packet, 10.0.0.1 packet, it is coming from this MAC address to this MAC address. This is the server's MAC address, and this is the PC's MAC address. It's a unicast. But the discover, both that goes from client, is a layer 2 broadcast. Now let us go back here. The paint. This DHCP has 4 packets which we just now saw. One is discover that goes from client to server as a layer 2 broadcast. It's a layer 2 broadcast. Layer 2 broadcast packets will have 12F as the destination MAC address. What about the destination IP address? Can anyone say? What will be the destination IP address? Yeah, 255.255.255. What happened to other 2% in the class? You didn't follow? You didn't understand? Okay, you understood? So it's a layer 2 broadcast. Doesn't mean that there won't be any layer 3 address. The layer 3 destination address will be layer 3 broadcast address. But don't call this as layer 3 broadcast packet. Layer 3 broadcast packet, if you say, then there should be layer 3 source address. There was no layer 3 source address. There was only 0.0.0.0. So, you cannot call it as layer 3 broadcast. Client is talking to server, but client don't have an IP address to do a layer 3 communication. It is just flooding by using layer 2 broadcast address. This is discover. Now, if the servers are available somewhere in the reachable distance, see, client is sending a broadcast and the switch is there, so the server was reachable. Likewise, in your house, if your laptop is a Wi-Fi laptop, the Wi-Fi signal layer 2 broadcast signal will search for your access point, your router in the coverage area. This router 1 in your house, it's a wireless router. This PC 1 is your laptop. They are not physically connected, but they are in the same radio frequency range. So the router, which is enabled with DHCP in your house, receives the packet now. It receives the packet and offers. It offers it's a unicast. Alright, so it's a layer 2 unicast packet. Sorry. Next, if the client is ready to accept the offer, only then it will send a request. Who is sending? Client will send a request to server. It sends a request asking to finalize the agreement. Again, that's a layer 2 broadcast. At last, as an acknowledgement, after registering the MAC address of the PC, let me show you that. This router, no? If you see now, it will have the MAC address of that computer to which this IP address is given. This is the MAC address of this computer. Let's go and check whether it is matching. IP IP, show IP. You see the MAC address? This is the IP address received, and this is the gateway received, this is the DNS received, and this is the server which gave that. It has leased for 1 hour, so now the timer is going on, so some minutes are reduced from 86,000. And now this is the MAC address I want to verify. Look at this. See these portions from here. This is the MAC address. So after copying the MAC address of the client to the binding table, it grants the address. Now I'm going to quickly go enable DHCP client on the routers. Router also needs an IP address. You can manually configure show IP interface brief. You see, as of now, this F00 don't have an IP address. What I'm going to do is I'm going to say interface F00, no shut, IP address you receive from DHCP. Now you will see an address coming automatically. You see that? It says 10003 is assigned, and this is the mask. Show IP interface brief. Now you can see that address. A few seconds before, this was not there, and this was unset. Now when you go to router 1, you can see 2 registration. This is another one. This comes with a lot of things when it comes from router. Just ignore, those things are not that important. It will come with various serial number informations and so on, hardware address and all, not just MAC address, few more information from routers. Let's go enable another router as a client. Router 2. You see show IP interface brief. As of now, there is no IP address here, but when I go inside and say get the IP address from DHCP, you will see the IP address coming now. Show IP interface brief. It will come soon. It will come now. Here you will see. See, it says address has been assigned. The advantage is it won't assign the same address to 2 persons. It won't assign. When you do manually IP address configuration, there are chances that we may provide the same address to more than one device. See, that's the wonderful advantage, very important advantage of DHCP. There won't be duplication. There won't be conflict. See, when you put the same address on 2 devices, there will be a conflict. Alright? That conflict won't be there if you use a protocol. Secondly, configuring thousands of computers with an IP address will take just less than a minute. Just less than a minute. All device gets IP address. As soon as you on the device, because they are already configured as a client, they will immediately send a deep discover packet, and then the offer comes, and then the request goes, and then the acknowledgement comes. DHCP is 4 packets: discover, offer, request, and acknowledgement. Acknowledgement is the final packet coming from the server, acknowledging the host as the client. It says, from now onwards officially, you are my client. You may use the address that I gave you. And client is happy. Haha. Really? Thank you. See, it's very happy. It has got an address from the server. Discover, offer, request, and acknowledgement. In short, DORA. D-O-R-A, DORA. That will help you to recall the sequence. discover of a request and acknowledgement. So a router can also get an IP address from another router. Not only a router, a PC also can get. That's what I have shown you here, right? Do you have any question on DHCP? All right. So you may not be able to do the lab now, but I'll be teaching you the command line interface from tomorrow class, where you will be able to uh, get into different modes and put the necessary configuration in order to manage a router. That is going to be our tomorrow's class, followed by something called static routing. After which I'll start subnetting, and then we will learn subnetting in depth, and I'll give you a lot of exercises so that in your free times you can do subnetting, and this router you can do some more hands-on, because you are exposed to router, you can play with. Today we'll stop here.